Yeah, Ketna, can you hear me?
Yes, sir.
All right. Look. So, Ketna, we started with a very simple idea about the chapter. What is the chapter we are talking about? Alternating current, right? The connected ones. Just a second, Ketna. think I've shared my screen. I have option to share on the screen. Yeah, Ketna, my screen is visible.
No, sir.
So now it's visible, right?
Yes.
Okay. So if you could remember in the last class what we discussed,
AC currents.
AC current, right? We had a small discussion about the AC current. Today, okay. Yeah. So let's see. Yes, Ketna, I think now you can see the screen. Maybe this screen might be visible, right?
Yes.
Okay. So look, we discussed about what is AC current in a very top view, right? We have not discussed yet like how to solve the problem based on this. Okay, what we are going to discuss, what is the important part of this. Okay, for this, like in this chapter, we are going to work more about like, how alternating current change works. Okay, in alternating current, we are not just going to stick with the alternating current. We are going to discuss about voltage also. Okay, we have to discuss LRC circuit, RC circuit, and like these kind of multiple mode circuits we have to discuss about. Okay, last 12. Yes. So Krishna, before going to like AC current, let's talk about how we can actually generate AC current, right? Because we already know what is AC current, but let's discuss how to generate that. Okay, then we are going to discuss about the properties. So just assume Krishna, you have a very small thing. What is it? You can see just the more things. Okay. Assume Krishna, you have this kind of one magnet. Call this as a north pole, and you have another magnet here south, right? So you know due to these two poles, you will be having magnetic field like this. Can I say this Krishna? Now, what I'm going to do about this vertical axis, I have one plate like this. So you can say this is a plate, and let's say this has a length L and height, let's say H. So what is the area of this? That is uh, L into H. Is this clear? This is multiply. Okay, simple multiplication. And out it now.
No, sir.
No doubt, right? Now, Kitna, look, what I'm trying to say is I am going to rotate this loop. Assume this is a point, okay? And this loop is not completely connected. It is something like this here, and it is going here. Okay? So I am going to rotate this loop about this vertical axis with omega. Make sense? So what does this mean? What I'm trying to say is, look right now in this position, you can say these many flux magnetic field path, right? So there must be some flux at this point. But when it gets rotated and it will come to this place, you will say that not even one flux is passing. So basically, by the time flux is changing, change in flux will result you EMF. Can I say this? This EMF will generate current. Is it clear, Ketna? Is it clear, Ketna?
Yes, sir.
So what my task is? My task is to calculate EMF. So if I'm able to create EMF, okay, if I got EMF, I can simply calculate current because I know if I know the resistance, I can easily calculate it. Okay. So our task is how we can generate this alternating voltage. So Kirtana, just assume for a while I'm removing this. Okay. I'm just removing it. I'm removing it also. Just assume that there's a one magnetic field in this direction like this. Okay, this is the direction, right? And this is a plane. So assume that at some time t, this is pointing towards look, this is pointing towards this direction. Okay. So what is the angle between the area vector? You can say this is the area vector. So this is theta. Okay. Angle between magnetic field and this is theta. So can I simply say what is this theta? You know that omega is nothing but what is omega? D theta by dt, right? Understood? So can I say this theta is nothing but omega times of two? Can I say this theta? Yes, we can say. So what is the flux right now at this moment? You will say the flux is nothing but d times of a. So can I say EMF which you are going to get that is nothing but negative times of d pi by dt? Yes, that comes out because look, magnetic field is constant all the time and area is also constant. So, so no, actually, this is flux is basically b cross this theta. Right? So this becomes dA cos theta. You know that this magnetic flux is constant because we have a constant magnet, right? Its area is also constant. It is not going to change. What is going to change is angle. Why angle is going to change? Look, when it gets rotated, this angle is going to increase, right? How you are going to get it. So this will be like B will come out outside. This will also you will be left with negative cos of theta by B. So when you differentiate it, what you are going to get minus dA d cos omega t dt. So when you solve it, minus look in what I can say differentiation of this cos again comes out as omega itself. Okay? So this will come out as dA omega times of sine minus sine omega t. Okay? This negative negative got cancelled. So you are left with dA omega sine omega. Is this clear, Ketna? So you can
Yes.
say the induced EMF across this loop is nothing but dA omega sine omega t. Now, Ketna, if I ask you, what is the maximum value of this EMF? So you know that E max will only possible if omega if your sine because look this is a constant part. What you are left with if sine omega t is maximum, right? Because this is the only thing which is variable. And what is the maximum value of sine omega t statement? What is the maximum value of sine with some angle?
90,
I think that should be no wait. What will be the answer statement? By 90. I'm asking for the value. I'm asking for the what is the maximum
ones,
value? That is one,
ones,
right? I'm not asking for the angle. So when omega t will be equals to pi by 2, in that case, sine omega t is max, right? So with this respect, we can simply say E max will come out as B A omega, and we can simply say this is nothing but E naught. So can we rewrite this equation as the simple general equation of E is nothing but look B A omega we already know that is the maximum value. So you have got sine omega t. Is it clear?
yes,
Yes. Now, if like assume this is the root, like so assume the magnetic field is produced across these 2 points, in this and this one, or anywhere it might be produced. So if I just connect simple resistance and I just complete the complete circuit, right? Assume this is R. So if I ask what is the maximum, like what is current in that case, you will simply say this is EMF E naught sine omega T by R, and this will become maximum possible current. So this will become I naught sine omega t. Is it clear, Kirtana? Look, I hope this might be clear, Kirtana. So that is fine. We have already seen average, right? So Kirtana, my task is right now I wanted to calculate average of my current, right? Whatever my conditions are coming. So Kirtana, look, let's go to calculation of average current. Average. Okay. Okay. So look, there's one more problem comes out here. If you go and make a graph of anything, let's look at the end of the day, it has some maximum value multiplied by the same thing. It also has some maximum value multiplied by the same thing. You know that average will come out in a similar fashion, right? Just the value will change. So let's calculate average current. If I make a graph of it, what is the sine curve? The graph goes like this. So Kirtana, average is nothing but integration of all points with respect to time. So there's an ideal thing that if I say this is 0, this is pi, this is 2 pi, right? And so on so forth. The average of this point, like for this point and this whole thing from one cycle, one time period will come out 0. Why? Because average is basically addition of all, right? So this is positive and same equal amount as you have negative. So this will result you 0 answer. Can I say this? You can actually check this also. Average will be represented by this way. So I'm going to calculate average from 0 to 2 pi, right? So you are going to get like I dt from where to where? Time is equal to 0 to time period t, okay, divided by complete time period, basically complete time you are going to go, right? So you can simply say I times of sine of theta omega t times of dt, and we are going from 0 to complete time period t, okay. Time period t basically because omega t is there and time is changing. So you can simply write like this. This goes as t. So now in this case, the average comes out as I as it is, sine, if you integrate that will become negative. This, if you put limit, what is the limit? 0 to 2. Let's see what I'm going to get. Negative I. What is cos omega t? This is nothing but 2 pi by 2 into, wait, 2 pi is nothing but 0. Cos 2 pi is 0. Okay. Is it 0 or something else? That is 1. Actually, cos pi is 1 itself. Okay. Something minus cos of 0 degree. So you got minus 1, 1 minus 1. That result is divided by 0. So you got average from 0 to t. That becomes answer is 0. Is this clear, Kitna?
Yes.
Okay. So do we really need to calculate average from 0 to this? Look, I wanted to calculate like then how you can actually calculate the value, because in this case we have got it is 0. So if I ask you what is the average value which current is flowing, does it mean it is flowing with 0 current? No, it is not flowing with 0 current. Understand? So we have to remove the range, we have to reduce the range, because if you see in this 0 to, when it is going from 0 to higher value in the positive side, I should have some average value which I can say, right, for this side also. But if I include positive negative complete, I am going to get 0 answer, right? So it's better to go to calculate average from 0 to pi only. Understood? My friend? So from I average 0 to t by 2. Why I'm talking about 2 by t by 2? Because t is the complete time period and t by 2 is a half time period. Either you can say this is also t by 2 time and this is also the t by 2. So it's your choice, whatever. So if you go that way, integration is coming out the same value. So I cos omega t. This time I'm going to put t by 2 to 0. So this comes out as minus. When you put t by 2, what the answer you are going to get in that case? I as it is, I naught. This is I naught. This is not I. Cos 2 pi by t by t. This is cos pi. Subtract cos 0. So what you are going to get at the end of it? Look at this carefully. This results you cos pi. What is the value of cos pi? Look, cos pi graph looks like this. Something like this. Okay. and at the bottom there should be t by 2 also, because right now the integration of time goes from 0 to t by 2. So bottom it will become t by 2. So this goes as t by 2 bottom, t by 2 bottom. Yeah, in the previous case it was only 2. I should have kept it. So this becomes Krishna minus the look. This will become I naught minus 2 divided by t by something like this. Is this clear, Krishna, so far? Yeah, Krishna, let me know if you are clear with
Yes.
this. Clear, right? Makes sense. So t by 2 divided by this is fine. Okay, that is fine actually. Let's leave it like this itself. So I average comes out as I think it will be minus I naught negative negative it becomes positive, so it becomes 4 by 4 I naught divided by t. What is t? You know t is nothing but 2 pi by omega. So put it there. So you will be getting 4 I naught divided by 2 pi. There's an omega. So this goes as cancel. So what you are left with, I this comes out as 2 I naught omega by this is the average I'm supposed to get in this particular case. I'll just divide it and get the real value. 2 by, yes, so this actually comes out as around 0.63 times of height. Okay, here's something I'm supposed to do. Yeah, there's one mistake was there. When you integrate something, the coefficient goes at the bottom. So this should be bottom, this should be at the bottom, this should be at the bottom. Here it also should be at the bottom, here it also should be at the bottom. So when this is at the bottom, you can see this get cancelled. So that's why you have to put this. Is it clear? Okay, look, the same way if I try to calculate average, if I calculate average EMF, wait, my mic is on mute. EMF. So again, I'm going to get the same idea. Like just to go for the same way, you are supposed to get 0.63 times of I E naught. In that it can be rewritten as 63% E. This can be rewritten as 63 percentage of I. That's a big deal. So just let me know if you have any doubt in this case. We have just calculated the average.
Yes.
It's clear, right? Okay, so the next one is Rm. What is this? Root mean square. This is nothing but your effective value. Okay, this is different from the average. This is effective value. Look, the problem is if you go back and look at the complete cycle, you figure out the value is coming out zero. So that's why the idea for the root mean square comes into the picture. What happens is simply do the square, whatever the calculation. Look again, how to calculate anything when you are supposed to do root mean square. Okay, idea is very simple. Take your parameter, do square of it, then calculate the average of it. Okay, root mean square of anything is nothing but your parameters squares average. Understood? For example, when I'm saying current, my current square of the current and average of that, not just average. Do the square and then get the average and then do it over. Okay, this is supposed to be answer. So, Kirna, um, can you try to calculate, let me see, can you try to calculate average this RMS current? Look, just look at the symbol over here. This IRMS will be nothing but I square, average of your I's basically divided by your yeah, I think it's back. So it should be connected once. Yeah, Kirtna, look, do one thing. I have given the way how you're supposed to solve it, calculate it. So try to get to the RMS value. I've already shared my screen. Try to calculate. Look, we already know how to calculate the average, right? So first, calculate the average of it and do at the last do a square of it. You'll get your answer. So try to calculate it.
Yes.
Okay.
Second, so you're not wrong.
We need to use it for the microphone. Second one.